Hi folks, this is Nat, and this is your video lesson on comparing and ordering fractions, decimals, and percents. We did a previous lesson on how to compare decimals to one another, and some of that's going to be useful here. But we're going to add in the ideas of fractions and percents for our comparisons as well. The other thing that we're going to be hitting on is the idea that you should be able to convert and compare numbers that are greater than and less than 1. So we'll be dealing with fractions and mixed numbers and decimal and percent values that exceed 1. So we're going to start out looking at different conversions involving fractions, decimals, and percents that are bigger than 1, so that we make sure that we've got that down before we move on. The first thing to know is that the rules really aren't all that different in this scenario. The things that you learned about conversions before are still going to apply. For the most part, we kind of ignore whole values when we see them and just do our standard conversion on the pieces, the fractional parts or the decimal parts. The whole numbers really don't change that much. So here's an example of that in this top line. I've got 3 3/7. To convert this to a decimal, the first thing I'm going to do is basically separate this into two pieces and ignore the whole number. The whole number is just going to stay put. 3 wholes is still going to be 3 wholes as a decimal. 3/7, I'm going to do my standard conversion rule. I can convert a fraction to a decimal by dividing, treating it like a division problem, dividing, in this case, 3 by 7. And if I do that division, 3 divided by 7 ends up being about 43 hundredths if I round. So I can just call this 3 43 hundredths. And that's the equivalent. From here, it's actually really easy to convert to my percentage. I can take my decimal, and in this case, it's probably easiest to just go decimal then percent if I need a fraction as a percentage. This doesn't come up all that much, but you should be able to do it. I'm going to take my decimal, 3 43 hundredths. I'm going to apply the butt cheek method and change that to 343%. Similarly, on this next row, 4 6/10, again, I can just apply that butt cheek method, multiply it by 100 if you want to think about it that way, and I end up with the percentage 460%. Going the other way, I'm going to kind of do the same thing I did on the top line with the fraction. I'm going to separate these into two pieces. I know I have 4 wholes, and that's going to stay the same. 4 wholes is always 4 wholes. The second part is 6/10, and if I remember my word form, 6/10 should sound pretty familiar. So it'll be 4 6/10, which I might reduce down to 4 3/5. Down here on the third row, 625%. Again, not too difficult. Probably not going to go straight to a fraction from that percentage. It's going to be easier to go to decimal first. So I'll apply my reverse butt cheek method, if we want to think about it that way. And that's going to be 6 25 hundredths, which again, if I think about that word form, the whole value stays the same, 6. And 25 hundredths is a nice fraction as it is. I can reduce that down to 6 1/4. This very last example is a fraction as well, and it is a fraction greater than 1. It's an improper fraction. So I could change this to a mixed number and then follow the same strategy I followed way up here. I actually don't have to. I can still just treat that as a division problem. Plugging it into my calculator, I can say 9 divided by 5, and I'll find out that that is 1 8/10. Again, butt cheek method gets me all the way to the end here, and I've got 180%. So hopefully what you're seeing is that conversions when you've got a value greater than 1 or some whole numbers in there are actually really not that different. Mostly we just ignore the whole numbers and work with the pieces and keep the whole numbers as they are. That gets us to the idea of comparison. If we have fractions, decimals, and percents, at some point we're going to need to compare one to another. And the biggest thing to remember here is that most of the time, particularly if the numbers are pretty close together, we don't really want to compare things that are in different forms. So I really don't want to be comparing a fraction to a percent or even a decimal to a percent. What I want to do is make a conversion so that the two numbers are in the same form and I can compare those more easily. So as an example, if I am trying to compare 5/13 to 35% and say, well, which one of these is bigger, which is least, which is greatest, I don't want to just try and do this the way it is. It just doesn't make sense. So I have the choice. I need to either convert them both to decimals, or I maybe want to convert my percentage to a fraction or my fraction to a percentage. Generally speaking, we don't want to convert to fractions because once you get to a fraction, you probably won't have the same denominators, in which case you really haven't improved your scenario. So most of the time we're going to be converting our fractions either to decimals or to percentages. And in this case, converting our fraction to a percent seems like a good thing to do. So if I want 5/13 as a percent, I am going to say, what is that out of 100? And I can cross multiply. 13x's equals 500. And then I can divide by 13 on both sides. And then I find out then that my percentage here is going to be, if I round, 38 5/10%. Now that it's a percentage, this is a really easy comparison to make. Comparing 5/13 to 35% may not have been easy, but comparing 38.5% to 35% is really easy. Obviously, 38.5% is bigger. The same thing is true if I'm asked to order a set of things like this. There aren't any percentages here. I'm dealing with decimals and then fractions and a mixed number. I'm not really going to do well with this unless I first take the time to convert my fractions, mixed numbers, into decimals. Again, I'm probably not going to try and convert my decimals to fractions. It won't help me a lot most of the time. So I've got 3 2/5 that needs to be converted. Well, I know the 3 is going to stay the same, and then I can just do the 2/5. 2 divided by 5, punch it in, I get 4/10. So that's 3 4/10. Same thing over here with 24/7. 24 divided by 7 ends up being 3 429 thousandths if I round. I chose in this case to round to the thousandths place because I had a decimal value up here that was also thousandths, and it was possible that I might have needed that digit to be able to compare accurately. Once they're all in the same format, it's just a matter of ordering them. So I'm looking at the whole value first. They all seem to have 3s as their whole values. I'm looking at the tenths value next. They all seem to have 4/10, each of my values. So now I'm looking at the hundredths place. I see 0 hundredths. That seems like it's probably going to be the least. So 3 40 hundredths came from 3 2/5. That must have been my smallest number. Then I see over here 0 hundredths again, but this one has an extra thousandth, so that's a little bit bigger. So 3 401 thousandths is my next biggest value. And then I see a 100th over here. That must be my next biggest. And finally, I see 2 hundredths over here. And, whoops, got to make sure I put this back in the form it came from. This is actually the number I'm thinking about, but it was originally 24/7. So when I give the order, I'll put it back in its original form. And that then is the order from least to greatest. So hopefully that all makes sense. The biggest thing we can kind of come back to is this idea of definitely don't try to be comparing different forms. It will probably be a lot easier for you in the long run if you make those conversions and then try to compare afterwards. And here are your practice problems for the lesson. For each of these, 1 through 4, I want you to order them from least to greatest, making sure that we put them back into their original form when we're done. Alrighty, good luck.